Okay, let's discuss today about epithelial mapping. Yes, it may or may not come under corneal topography or tomography, but yes, it's crucial whenever we try to diagnose ectatic disorder because epithelial mapping is very, very crucial. It's not just crucial, it's very, very, very crucial. That's why I want to touch this topic. And I'll show you some maps from my back from Nepal I have collected, and I think that maps will help you a little bit, but we have to understand why epithelial mapping is so important. Okay, and so I will quote a lot of papers today, so let's see how it goes. Okay, so basically what is epithelial mapping? It means corneal epithelial thickness changes around the corneal steepening location and can mask the corneal signs of keratoconus on anterior topography. So basically, corneal epithelial is very, 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 very sneaky. It can change its thickness according to the steepness of location of steeping cornea. So which is basically keratoconus means what? It becomes cones, isn't it? So whenever cone is pointing out, at the same time that particular area becomes thinner in corneal epithelium becomes thinner so that it can mask the earliest changes in corneal topography. So basically, why epithelium thins at the steeping location is to hide the irregularity of the front surface of the cornea. Why irregularity of the front surface? Because we know, and even I know, the front surface of the cornea has maximum power, isn't it? 48. So if there is change in 48 diopter tool, then it will create a lot of aberration. That's why epithelium try to make it smoother if possible. So basically, epithelial thickness map provides the higher sensitivity and specificity in detecting keratoconus than topography and tomography alone. It's fantastic thing that you understand these things. If you do topography and tomography alone, but if you add epithelial mapping, so don't confuse topography and tomography. Basically, tomography is still gold standard whenever you're diagnosing keratoconus. It's still gold standard. Don't worry about it. But whenever you add epithelial mapping, it's very sensitive and very good. You add epithelial mapping with topography. It's great, actually, not just good. Okay, so sensitivity becomes very high, specificity is actually high. So I always do that. I don't always. We had that tomography, bone series tomography, but I always told my students, just give me epithelial mapping too, so that I can understand things more clearly. Okay, so epithelial thickness map may help to identify keratoconus who have otherwise normal topography, because sometimes it's sneaky. Okay, especially in case of early keratoconus, and to rule out the keratoconus, some patient with equivocal tomography and topography. Yes, definitely the topography and tomography is, yeah, quite a bit there, but it's very important that you rule out something. Okay, so understanding the predictable behavior of corneal epithelium. What are the predictable behavior? Okay, epithelium thickness are clearly compensatory response to change the stromal surface and can be summarized. What is that compensatory mechanism? I'm going to tell you here. So thickens in the area where tissue has been removed or flattened. That's very important. Whenever stromal tissue is removed or flattened, then epithelium becomes thicker. Okay, that's the concept. Thin over the region are relatively elevated or curved, has been steepened. If stroma becomes a little bit steeper, then epithelium thin at that particular area. That's the concept. If stroma is removed or flattened, then epithelium thickness grows. If stroma is elevated in keratoconus posterior surface, stroma is elevated, then anterior surface stroma is elevated. At that particular time, epithelium becomes thin. Okay, that's the way epithelium function. And the magnitude of epithelium change correlate to the magnitude of change in curvature. It's very important. Magnitude of epithelial change. So, and another thing is amount of epithelial remodeling defines by the rate of change in curvature and irregularity. The more epithelial remodeling, the more local irregularity. Means if epithelium remodeling is quite fast and more, it means irregularity is more. Okay, it's very important to understand that how why epithelium, corneal epithelium functions like that. So epithelium thickness profile in normal eye. You have to understand first normal, then we will go to abnormal. Okay, epithelium is not a layer of homogeneous thickness regulated by eyelid mechanism. It's not a layer of homogeneous thickness. Definitely epithelium is thicker in the periphery and thinner in the center, and its definitely thickness is regulated by eyelid mechanism too and blinking. Okay, how? The average epithelium is basically 5.7 micrometer thicker in the inferior than superior. It's very important. 1.2 micrometer thicker in nasal than temporal. Because why? Because temporally, just remember blinking mechanism. Eyelid come from up to down. That's why downward portion is thicker, because superior portion is pressed by the upper eyelid. At the same time, blinking mechanism is always from zipping. So you remember from contact lens chapter 2, zipping means temporal to nasal, isn't it? Temporal eyelid closure mechanism, it comes from temporal to nasal. That's why temporal is thinner, nasal is thicker, but it's very small amount, which is 1.2. And the mean central thickness is 53.4, standard deviation only 4.6. So it's basically data is taken from this paper. Okay, the thinnest epithelium point within the central 5 mm corneal displacement on average is 0.3 mm, that's temporally, and the superiorly in the reference corneal vortex, but it's completely okay. So this data is very important. Okay, within normally you say epithelium is around 54, 53, 54 micrometer thick, and just this understand these two data too. Okay, it's very important you understand with the eyelid blink mechanism. See, here's the color chart. Okay, scale. You see green means 55 around center. Okay, so red means thicker epithelium, blue means thinner epithelium, isn't it? This is 0 from, and this is 0 means this is the center. Okay, superior is what? Thinner, because of the eyelid movement. Inferior is thicker. That's what we have told you, isn't it? Temporal is thinner, nasal is thicker. This difference is 5.7. I'm talking about just grossly, and this difference is 1.2. Inferior temporally, basically, not inferior temporally. Nasal and temporal means nasal is thicker and temporal is thinner. The difference is 1.2. Superior is thinner and inferior is thicker. That's why you get the red here, isn't it? This is thicker, inferior. Superior is thinner. Temporal is thinner. Nasal is thicker. Okay, that's the difference. That it is basically, you can take it as a very normal, what normal epithelium looks like. Okay, it's very important. So epithelium thickness profile in keratoconus, I have uh, taken from this paper also. The epithelium thickness in keratoconus patient exhibit epithelial donut pattern. This word you will see in your life a lot. Epithelial donut pattern, characterized by the localized central zone of thinning surrounded by the enormous thick epithelium, and the lack of donut pattern would indicate the normal topography and was not due to keratoconus, but it's not that always. Okay, but it's a typical finding in keratoconus, established keratoconus, I would say, is basically donut pattern. It means center thin and the periphery center thin, and thin epithelium is covered by thick epithelium. Okay, in case of keratoconus patient, so on an average 45.59 at the corneal vertex, thinnest point is 38.2 and thickest point is 66. That's basically from this research. Okay, location of thinnest epithelium within the 5 mm displaced on average with the reference axis. See, temporally, inferior temporally, can you see? Inferiorly displaced and temporally displaced. So this data is basically displacement. So basically means thinnest location is exactly above the elevated point. That's always there. And whenever you have corneal topography and you have epithelial mapping, what you do is posterior elevation of topography you match with epithelial mapping. Okay, So basically, if these two, the posterior elevated point and epithelium map thinnest point matched, then yes, there is keratoconus. It's very, very important. The exact position matching is central important. If you see the posterior elevation like superiorly and the epithelial mapping thinning inferiorly, and that's quite a different story. Okay, it's not keratoconus like it's not likely keratoconus, so it's very important to understand this concept. So thinnest location is also inferior temporally, as we have already discussed. Keratoconus is inferior temporally displaced cone, isn't it? No, usually inferior temporally. It's not like it has to be there, but yes, usually out of 10 I think 7 8 cases are inferior temporally displaced cone, isn't it? So this is the pattern what we call donut shape. Let me tell you why it is donut shape. Central thin and this periphery surrounded by center, this is red, is thick. Now it's look like donut shape, isn't it? So that's what donut shape is. However, in advanced keratoconus there are stromal loss of, so there are stromal loss location of the cone, and this means that rather than cone being elevated at the rest of stroma, this region is now the depression. Therefore epithelium changes from being thinnest over the cone to thickest. So this region, as it is compensate for the depression instead of elevation. So basically means, see, in case of advanced keratoconus, if there is a stromal scar, or if there is Bowman's membrane disruption, and there will be another story. I'll show you one case. I have one case in the last of the slide. I'll show you. Okay, in case of advanced keratoconus, that's another story. It's always another story. Don't always think that you will get exact donut pattern. That's not like usually in clinics. So in this paper from 2009, this is a very beautiful picture I wanted to show you. See, topography in case of, I think this is very very normal case, this left hand side, and right hand side is keratoconus case. Can you see this picture? Don't you think it's like, just watch carefully this point, you will see a crab claw pattern, very small crab claw pattern. Okay, see, focal crab claw pattern. And posterior elevation, I have already told you, don't, yes, anterior elevation it's good, but posterior elevation you always have to suspect. This is posterior elevation, huge elevation, elevated area, isn't it? Reddish elevated area, and at the same time anterior also follows that. And can you just see these two picture, this and this, isn't it? This is elevated point, and exactly that point thinnest epithelium is there, and that's why it's keratoconus. Just understand this point, 2 point posterior elevation and the thinnest location is exactly matched with each other. So it's very beautiful picture. I think it's very very good to explain things as usual. But in case of normal, see, there is nothing. Is there? It's normal. Epithelial mapping, superior is thinner, inferior is thicker. It's normal basically. So I love with this paper, the 2016 paper, subclinical keratoconus detection and pattern analysis and corneal epithelial thickness map with the OCT basically. So it says, it's very very clearly says, subclinical keratoconus versus normal eye, pattern standard deviation values significantly higher for corneal, first corneal, then epithelial. See, there is high, and stromal a little bit less, but it's still less than p value less than 0.0. Thickness map in the formal. So basically these three things has very very sensitivity, but definitely thickness map of cornea and thickness map, basically pachymetry and epithelial mapping, epithelial thickness is very sensitive for detection. Okay, see this thing. So three pattern standard deviation, variability, what is sensitivity and specificity. So can it, stromal is very less as compared to pachymetry is good, but epithelial mapping, all of three epithelial mapping has good sensitivity, isn't it, and good specificity like 100% almost. So it's very good. Epithelial mapping pattern standard deviation is very good, and specificity and sensitivity from this paper too, it's very good, very very good. And these are three things they see: normal, subkeratoconus, epithelial mapping, pattern standard stromal, and pachymetry. In this pictures too, you can easily say that epithelial mapping and pachymetry is very good on detection thing. Okay, see, this is case in abnormal is normal, but subkeratoconus, you can see Venn diagrams showing the overlap between pachymetry epithelial mapping instrument. So a lot of thing, definitely three of us is very good, but yes, there are few data which is also epithelium and pattern standard deviation, sorry, pachymetry pattern standard deviation false. So basically pachymetry and epithelial pattern standard deviation is very good on detection subclinical keratoconus. I love this with this map, and I have taken from same paper. So can you see this? It's normal group and it's subclinical keratoconus group. Can you see this simple thing? See, temporal, inferotemporal thinning of the pachymetry, inferotemporal thinning of the epithelial mapping. So basically, it's inferiorly thinning, a little bit temporal thinning of the stroma. It's look like same, isn't it? It's very same. So in this paper for 2021, there is two-step decision tree, and I love that concept. And basically, I have put it because of this two-step decision tree to distinguish keratoconus from the normal eye. First step is the main parameters. So they have taken this paper from keratoconus detection using OCT, corneal epithelial mapping, and map parameters and patterns. So basically, what they do, they take pachymetry, so less than 550, obviously suspect. Pachymetry minimum and maximum, if there is difference if minimum pachymetry place and maximum pachymetry is 71 micrometer, and then they take pachymetry superinasal and inferotemporal difference, it's 20 more than 28 micrometer, and epithelium standard deviation is 1.88 micrometer. Okay, okay, that's the case. And then what they did, if this parameter fits, then they have, if they don't fit any parameters, then it will be no, definitely no keratoconus. If parameter fits, then second step, what they do, map the pattern. And map pattern means coincide thinning epithelium concentric thinness. So what do you mean by that? See, so map patterns mean coincide thinning epithelium concentric thinnings. Basically means the epithelium thinning coincides with the posterior elevation or not. Epithelial thinning coincide with the uh, posterior anterior elevation or not. And if it is yes, then it's keratoconus. So that's basically two parameters are very 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 I think very very uh, good, but I don't think this paper uses that particular pattern. I think that it uses the coincide thinning ring and the posterior elevation from the OCT only. But we in normally in our setups in hospitals, we think like posterior elevation of the posterior elevation of from the keratoconus, sorry, topography, and that match with the epithelial thinning from epithelial mapping. So this steps, I love that this step, that's why I put. So from this paper shows the result, the decision of the tree correctly classified all normal specificity 100%, means normal is normal, and had good sensitivity in detecting manifest keratoconus like 97.8, and subclinical keratoconus like 100%, and formophoristic keratoconus 73.7%, and that's a very good decision making tree. So I think I should introduce you. So I will show you some papers, so show you some epithelial mapping from the clinic. See, this is basically pachymetry from right eye and from left eye, and this below two as epithelial mapping, and there are very few beautiful pictures. See, so this is minimum and this is maximum, right eye left eye, and the minimum minus maximum difference the same is here also for pachymetry, and the standard deviations. Okay, that's matter. This epithelium is basically within the 5 mm zone. Okay, this is very normal, we wouldn't have to think about it, it's very normal. 556, 56, 57 epithelium, it's good. Second is also same, it's very good, normal. Okay, basically I want to show you this is the stromal map. I have ticked the stromal, basically means this is not an epithelial map in this picture, this is epithelial map. So lower one is stromal map basically. Okay, We can remove epithelium and we can just see if how its stroma is going. Okay, that's the case. So this is again normal. So in this case, can you see this is the stroma of the removing epithelium? Okay, see this is the case. This is the case of keratoconus. So can you see thinning of this area and surrounding by thick area? Thinning means, see, bluish area means 40, around 40. This star means the thinnest area in this machine particularly. So this is pachymetry. So it's also thinning here, and exactly thinning of pachymetry and the thinning of the epithelium at the same point, isn't it? So see, in this particular case, pachymetry, and in case of this is epithelium. See, epithelium minimum is 41, maximum is 56. What is the difference? 15. If you remember my first and second slide, maximum difference between minimum and maximum in normal case, what I have told you, 5.7 from the paper. Is it that? No, it's very, very high. Very, very high. Standard deviation is 4.5. It's greater than 3. We suspect a lot. It's like 4.5. It's great. So difference is not 5.7 or all. It's 15 lakhs, 3 times. So that's great thing to understand. See, 119 difference between pachymetric minimum and maximum. What was there in this paper? 71, isn't it? It's like how much here? It's 119. So that's, it's a very, very frank, clear keratoconus case. Can you see it? Once again, it's thinnest point at the same thinnest point in pachymetry. Okay. So this is what this is stromal map. This is pachymetry map, and I remove epithelium and I got pachymetry, isn't it? When you remove this epithelium, can you see the epithelium in this picture? Just epithelium here. So I remove epithelium, then you got pachymetry. So in pachymetry there is thinnest point, isn't it? This thinnest point means, see this color picture. It's very important. So again, it's frank keratoconus, isn't it? Right eye and left eye, both eyes. So it's very, very frank keratoconus. See, epithelial pachymetry thinning. At the same time, see epithelial thinning and inferotemporally. So that's how I have told you it's important. So, so in between right and left eye, this is right eye and this is left eye. In between right and left eye, can you see the minimum thickness is 38 in right eye and 42 in left eye. From this also you can tell that right eye is more keratoconic. And comparing these two chart, epithelium chart, which one you look, it look like more keratoconus, isn't it this? Because of the thinning. And again, I will tell you one thing which is very important. If there is a greater thinning here and surrounding by the greater thickening, it's always there like this. Can you see? If it is minimum is 38, the maximum also greater 66. If its minimum is lesser 42, maximum also lesser, which is 60. Isn't it? It's fantastic, isn't it? And another thing, I'll tell you why I am confirmed that right eye is more keratoconic. See, standard deviation. Right eye minimum maximum difference is for 28. My goodness. Left eye minimum and maximum difference is 18. Though left eye has enough of standard deviation, which is greater than 3, it's 4.7. But see, the standard deviation of right eye 7.9. Greater than 3 standard deviation, we always suspect it's keratoconus. It's like 99.99%. But it's definitely pattern matters. But it's 7.9. My goodness. Can you easily tell people that right eye is, this eye is keratoconic, more keratoconic, obviously, isn't it? So more elevated posterior surface, because that's why more thin, and the thinner point is more thinner and thicker point is more thicker. So it's very, very important to look like this. So again, another case, and same case, just removing its stromal map. Stromal map also shows thinner point and this thinner point, isn't it? It's very simple. So this is the case I want to discuss to you. This is very, very peculiar case, and in this case, I have seen this. It's like actually uh, it's the rupture of the Bowman's membrane, and there is uh, scar in cornea, and keratoconus is like peak. It's very, 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 very big. See, pachymetry is like very thin, very thin. Okay, it's very thin, and power is extreme high, and posterior elevation. I'll show you. See this case. So keratoconus vertex back is 223, greater than what we suspect, 20. What do you mean by that? 223. It's like crazy, isn't it? Keratoconus vertex front, in case of bone series, we think like 10, 12 is suspicious. What is there? 96. Thickness. How much thickness we suspect? Around less than 500 or 490. Let's take an example. It's 290. It's way thinner, isn't it? So in this case, before scleral lens trial, high order aberration is 79. In case of keratoconus, we suspect high order aberration is greater than 0.5. Is, yes, we suspect there. Not keratoconus, but it's high order aberration is high. It's like 79. And after putting scleral lens, high order aberration come to 1.9. It's still high, but that's why scleral lens is a magical lens. From 79, it comes directly to 1.90. It's, isn't it great? Here, point spread function, you cannot see anything. It's like spread. Now there is at least point. Okay. Here, this picture, can you see? Nothing. But here, you can now comprehend. So basically, higher aberration from 79 comes to 1.91. That's why we call it scleral lens is a magical lens in case of keratoconus. So that particular case, this is the actually topography. Sorry, epithelial, pachymetry and epithelial. Pachymetry in central 1 mm is minimum is 265. Let me tell you one thing. Here, thickness minimum is 290, isn't it? So actually, it's way more, way less than that. Actually, 265. That's why in these extreme cases, don't rely on topography. Just rely on uh, ultrasound pachymetry. Okay. So in case this, see the difference, minimum maximum 137. Here is another crazy story. Is there any pattern in epithelial mapping? No, not at all. Why? But there is a pattern in pachymetry, because pachymetry is thinner in inferior temporally. But there is no thinning in epithelial mapping particular pattern because of the disruption of Bowman pattern, because of the scar. There is no pattern. Okay, there is no thin like extreme thing like this color, black, and this color thick like extreme thing, this color. Okay, so there is no pattern, particular pattern. But yes, in this eye, there is a pattern, but not in left eye. But in stromal map, in stromal there is a pattern. See this pattern, thinning over exactly inferior temporal, thinning here. So this is a good case. I think I've seen this case, and there is no pattern in epithelium because of this scar, and you will see in your life this type of cases. Okay, so I think what is the take home message? The OCT, corneal, and epithelial thickness map parameter and pattern can be used conjunction with the topography and improves keratoconus. I will always tell you, it's not just, don't take epithelial mapping for only one thing for diagnosis of keratoconus. Yes, if you want to choose one machine, then it will definitely be corneal tomography, but not only corneal thickness epithelial mapping. You have to add epithelial mapping with corneal topography. And coincidence thinning pattern on corneal or epithelial maps, and the concentric thinning pattern on epithelial thickness map are unique pattern. Basically, you have to have corneal thinning at the same time epithelial thinning and posterior elevation. Same. So epithelium pattern standard deviation whereas can be used for the diagnosis keratoconus with high accuracy, while pachymetry pattern standard deviation whereas also can be useful in early. So basically, we do two things: pachymetry mapping and epithelial mapping and posterior elevation from the topography. Okay, so that's it. There are a lot of, you can pause and see all this paper, you can read all the paper, which is very, very great papers. Okay, so I think that's it. It's long video but worth it. I think you get some good points on epithelial mapping. So bis dann, cheers.